All right, everyone, it's me again, your teacher, Mrs. Williams. So I already recorded this once and I'm having to redo it again. And in my first video, I said, I hope I don't have to redo it again, but I recorded without sound. Luckily, it's not 11 p.m., so you're still going to get a fresh version of me, if not better than the first video. Okay, so we're going to just do two parts of this lesson. In terms of the video, I'll have some other stuff for you guys to work on after you get through this component. But the focus of this lesson is coordinate pairs, exactly what it says here. So we're going to be working with X and Y values. So specifically, if I were to, give you an X value, or if I were to give you a Y value, let's say these were given, if I know one of the values, I essentially want to be able to say I can find the Y value or I can find the X value, depending on which one I have. So that's our criteria today to find solutions. We would call these ordered pairs. I would call them solutions to linear equations. Again, if I'm given one of the values, to start from, I can find the other value. So we start off with this idea of creating our own values for the equations that are listed. So it says for each equation, choose a value for X and then solve it to find the corresponding Y value. So this is pretty open-ended. So what you come up with is probably not going to match what I come up with, and that's totally okay. I will go through some examples. I'll do an example for each one, but I'm going to ask you to now pause and then go ahead and just work through those and then come back and listen to what I have to say. I also just realized I probably should have checked to make sure the volume was going to work this second time, but I'm already into it, so let's just hope I don't have to record it a third time. Go ahead and pause. Welcome back. If you didn't pause, then great for you still being here. I don't know. What do you say to that? So, okay, here we go. First one, I chose to let X be equal to 7. That was just a value I picked. So I'm going to say X is 7. So when X is 7, I'm going to substitute that in for X. And I know I have to find Y. 6 times 7 is 42. And then it has to be equal to 7Y, and the only value that would work for this is when Y is 6. Kind of ironic since those were values that were part of my equation. Whoopsies. So Y would be the value that goes along with X equaling 7. So the solution to this equation, I would say is, or a solution to this equation, it's not the only one, because again, you might have came up with something different, would be 7, 6. Maybe I used a different value. Let's say I used, I don't know, 2. Sure, why not? Let's say I said X is equal to 2. What would Y be equal to? Well, 6 times 2 has to equal 7Y. 6 times 2 is 12 times 7Y. This isn't going to be a whole number. This is going to be a fraction. So it's actually going to be 12 over 7 is equal to Y. So another solution I could say 12 over 7 would be 2 comma 12 over 7 for that equation. And again, you might have picked something different. Okay, as I continue, the next one, I chose to let X be equal to 3. So I know here, I'm trying to find out what Y is. So I have 5 times 3 plus 3Y has to equal to 9. So I have 5 times 3, I'll write it over here, is 15 plus 3Y is equal to 9. And then I'm going to subtract 15 from both sides in my head. So 3Y has to be equal to negative 6, and then Y has to be equal to negative 2. So the value that would be paired with X is going to be negative 2 for Y. So a solution, not the only one, it is a solution to number 2. The ordered pair would be 3, negative 2. So again, bringing you back to this idea of if I'm If I'm given the x value, I could find the y value. If I'm given the y value, I could find the x value. In this warm-up, we're just creating those values. Okay, then the last one, I'm going to let x equal 6. You might have done something different. So I'm going to say y plus 5 minus a third times 6 is equal to 7. I was strategic in choosing this because I didn't want to work with a fraction, so I picked something I can easily take a third of. So y plus 5 minus 2 is equal to 7. 5 minus 2 is 3. So y has to equal 4. So a solution to this equation is 6, 4. It is not the only one. Okay? So let's go to the next piece. I'm going to try and have all of this done within 5 more minutes. So that way it's not too long of a video. Okay, so you have this graph. And there are 3 lines. I'm going to highlight them all different colors. So I'm going to say line N, line M, and then line L. And all of them are linear relationships. Linear meaning they do create a straight line. There is some sort of rate of change to each of them. I didn't like that squiggle. I'm redoing it. Okay. And all of these lines can be represented with equations. They don't give us those equations, but they are telling us that these relationships could also be represented with equations. Okay, that's something we've been working with. For each statement below, decide if it is true or false and explain why or why not. Okay, so again, I would pause. I would go through these 8 questions on your own and then come back and join me for the explanation to check your work. And yeah, go ahead and pause. Welcome back. Or if you didn't pause, hello again. Okay, so I'm going to just quickly go through and I'm just going to say true, false, and then I'll go a little bit into detail. For those of you who feel like you need the explanation, want the explanation for any of them, okay? All right, so we should have come up with, let's use this color here. So we should have come up with false, true, false, false, false. Scroll to number 6. Oops. Well, you could see them there from my first try. True, false, and false. But it's going to bug me that they're not the same color now, so I am going to write them again because that's just how I roll. True, false, and then false again. Okay, so let's just talk a little bit just in general. In order for something to be a solution to a line, the ordered pair has to fall on the line. And a lot of these statements kind of challenge you to think about where those points were at. So like the first one being false, 4, 0, if I think about where the point 4, 0 is, we use red, okay. 4, 0 is right here. I'm sorry. That's not where it is. 4, 0 is right here. There we go. I was going to say it's false. That doesn't make sense. Okay. 4, 0 is not on line M. What is on line M is this value here. This value, we would say, is 0, 4. So 4, 0 is not on the line. If you wanted a formal explanation, 0, 4 would make it true. Okay, going into number 2, that was a true statement. The coordinates of point G, it fell on both lines, M and N, so that was true. For number 3, x equals 0 is a solution of the equation. Again, we're working with ordered pairs. This doesn't tell me anything about a y value. I need a y value. I need a y value with x. I need an ordered pair to make that decision. So there wasn't enough information for me to make that conclusion about line n. Okay, going into number 4, 2, 0 makes both the equation for line m and the equation for line n true. So 2, 0, let's take a different color here. 2, 0, which is right here, doesn't fall on either of those lines. What does fall on the line is point G, which is 2, 2. So 2, 2 would make it true. But 2, 0 doesn't fall on the line. Number 5, there is no solution for the equation for line L that has y equals 0. So let's talk about if I were to extend this. I'm just drawing like kind of a gray line. And what if I were to extend line L? Well, eventually it's going to hit my x-axis, right? So to say there's no solution for the equation that has y equals 0, well, whoops. If I were to find the ordered pair for this, this would be whatever x value it is, and y would be 0. So there is a solution, you just don't see it. Remember, lines are they are infinite in both directions, right? So this line will keep going on and on and on. So it will eventually hit that x-axis. Okay, so that one we would just say is false. It will eventually. Oh no! Siri, you could just get through this video. That'd be great. It will eventually cross the x-axis. We just don't see it. Okay? How am I doing on time? Oh, I'm a little bit past how I wanted to go. It's all good. All right. Question 6. The coordinates of point H are solutions to the equation of line L. We said that was true. It is a point on the line. There are exactly 2 solutions for the equation of line L. That is false because line L, which is my blue line, although it shows 2 points, I will emphasize those 2 points here and here. Those are not the only solutions to line L. There are points that we don't see. For example, this right here is a point that is not labeled, but it is a point on the line. It is a solution. This right here, again, this here, this here. The ones that are not even shown on the graph. There are infinitely many points that lie in that line which make those solutions. So it's not just 2. Last but not least, there is a point whose coordinates make the equations of all 3 lines true. That is false. If you look at where these lines intersect, the green and the pink intersect each other. The blue and the green intersect each other, and the blue and the pink intersect each other. There is no spot where all of them intersect. Now, I could say, if I thought about this line, I don't know if I can move it. Let's see if I can move it. No, I can't move it. If I translated that line up, so that way it were to intersect here, then I would say true for that. But that's not the case. All right, I did okay on time. Hopefully you guys got some good notes from this, and be ready for the next round of practice. See you later.